In this video, I'm going to be talking about how to solve the classic boat crossing a river problem using vectors and a little bit of trigonometry as well. So the first thing you want to do is you want to diagram your vectors involved in the question. So we have a boat that's going 5 meters per second to go across the river. In both of these scenarios, the only difference is the current of the river for this one is going to the right at 6 meters per second, and the current for the second one is going to the left at 8 meters per second. So what you want to do is you want to use the tip to tail method and connect the two vectors and draw the first one, and wherever the first one ends, that's where the second one starts. That's why it's called the tip to tail method. And then we'll draw in the resultant vector, the final overall vector from there. All right, so I went ahead and drew in both the vectors, and like I said, when you connect vectors together, you connect them tip to tail, so wherever the tip of one vector is, that's where the next one starts. And your answer, which is called the resultant, always connects the very starting position to the tip of your ending position. Same thing with this one, the beginning of your very first vector to the tip of your very last vector. And then we can call that v for a velocity, or we can call that r for a resultant. It doesn't really matter which variable you use. Either way, you're going to solve it using the same method. So what we're going to do is, since we have two parts of a triangle and we're looking for the hypotenuse, we're going to use Pythagorean Theorem, which is a squared plus b squared equals c squared. The a and the b are two sides of the triangle that aren't the hypotenuse, and the c is the longest part of the triangle that is opposite the 90-degree angle. So what we're going to do is use the Pythagorean theorem and then solve for our resultant for each of these triangles. All right, so what I did is I went ahead and used the Pythagorean theorem for both of these. The method looks very similar to where you take each side of the triangle, square them, sum them up, and then you want to take the square root of both sides, and you could either leave it as the square root of 61 if you want the exact answer, if you put in your calculator, and then find the approximate, it's 7.81, and then I did the similar thing for this side, except I got a slightly larger number because we have a larger vector over here that was added on to the 5 meter per second velocity of the boat. All right, now the final thing that you may need to solve for is the angle to get a very specific direction of which way that vector is pointing. So we know that this specific vector is about 7.81, and then we'll say that's in meters per second, which is some kind of velocity, and then this one is 9.43. And that's in meters per second as well. So now the final thing is you may need to solve for a particular angle, and if you do, you would need an inverse trig function. We could use the inverse of sine, cosine, or tangent. It really doesn't matter which one you use because we have every side of the triangle. When you're choosing between trig functions, you normally choose based on what sides you have, but we have all of them. So what I'm going to do is I'm going to go ahead and use the inverse of tangent. Okay, and then tangent is TOA for SOHCAHTOA, so it's TOA. So I'm going to take the opposite end. So opposite of this angle is a 6 over adjacent, the one right next to it, is 5. Okay, and this one's going to be the hypotenuse because it's the longest side of the triangle, opposite of the 90-degree angle. So if you take the inverse tangent of 6 over 5, then you get 50.19 degrees. I'm going to do the same thing from the other side. I'm going to use the inverse of tangent. Opposite this angle is going to be 8. And then adjacent from this angle is the 5. And that would give us an angle of 57.99 degrees. So we can go ahead and draw that into our diagram if we want to. And depending on the style of the question or the preference of your teacher, you can leave it like that and just include the angle in your actual diagram, or you might have to use a specific type of notation. So one additional detail you may need to add based on the style of the question or what it's specifically asking, you might need to add some cardinal directions to that. Okay, so what I mean by that is you may have to put something along the lines of 50.19 degrees east of north. Okay, and what does that mean? If you take a look at the cardinal directions, north is straight up, south is down, east is to the right, and then west is to the left. So when you're saying east of north, well, this is north, right? So then if you're going east of north, that means you're tilting 50.19 degrees towards the east from directly north. Okay, you can do the same thing with the other one, except this thing would be 57.99 degrees west of north. So it's called 57.99 degrees west of north because for this one, it is tilting away from north, so north is going to be straight up. And this time it's tilted to the left, and remember, to the left is towards the west end, so you're tilting away 57.99 degrees west of north. Okay, so I hope that was helpful in helping you set up, understand, and solve every part of the classic vector boat problem. Thank you for watching and listening.